Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleo teacher, Jen, and it's time for Fossil Friday. This is Joermungandr bolti. It was discovered in the Carboniferous Mason Creek beds of Illinois quite recently. It was described in 2021 by Arjun Mann, Amy S. Calthorpe, and Hilary C. Madden, and published in Royal Society Open Science, which means if you want to read about it, you can, and I will put the link in the description. So, the Mason Creek beds represent a large river delta system that emptied into a bay mixing fresh and salt water. Illinois was a tropical paradise at the time, sitting only 10 degrees north of the equator, at least where Mason Creek was. Obviously, not all of Illinois was, but hey, all of Illinois would have been a tropical paradise at this point. The fossils in the area were rapidly buried by sediment broken down by bacteria, which formed carbon dioxide. That carbon dioxide bonded with dissolved iron in the groundwater, forming the iron carbonate siderite, which preserved detailed casts of the bodies. Lithification formed protective ironstone nodules like the one in which Joermungandr was found. It lived alongside things like calamites, which we will learn about next week, lepidodendron, which we delved into a few months ago, so if you want to check that video out, you can, an early gymnosperm called chordates, and then over 320 species of animals, including the shark Bandringa, the giant centipede relative Arthropleura, and the tiny temnospondyl Nagini mesonense. Joermungandr belongs in the clade Tetrapoda, the clade Reptiliomorpha, or Panamniota, depending on who you ask, and the clade Recumberostra. Unlike its namesake, the giant world serpent, Joermungandr was less than 2 inches or 5 centimeters long. It has lots of tiny conical-shaped teeth, 40 presacral vertebrae, so that's cervical and dorsals, that's right until we get to the hips, and only 7 caudal vertebrae. This translates to a very long body and a fairly short tail. Several parts of the body preserved small oval-shaped, slightly overlapping scales arranged in linear rows, which you can see is sketched out on these models here. Under a microscope, the dorsal, ventral, and flank scales appear to have a shell-like pattern on their surfaces. I mean, how cool is that? The cranial scales appear to be smoother, though. The elongated body of Joermungandr and others like it are associated with increased fossoriality. In other words, a long, flexible body makes it easier to burrow underground. There is also a reduction or loss of gastralia, the belly ribs found in many reptiles, including dinosaurs. And this makes sense because the extra bones would decrease flexibility to the ventral side of the body, and they don't want that if they're digging holes. Thanks for coming to today's lesson, and make sure you tune in Monday to learn about the overall climate of the Carboniferous period. Have a good weekend, and fossilize you later.